Trawl lines are very long lines, many in excess of a kilometer, to which hundreds of shorter lines with baited hooks are attached. Pelagic trawl lines target fish such as swordfish, sharks, mahi-mahi, etc., up in the water column, or tuna. These were used in the movie Perfect Storm. Demersal trawl lines target bottom fish such as cod, haddock, and halibut, and these are especially useful when the bottom is too rugged to use nets. Traps remain the primary capture method for cryptic animals such as crabs and lobsters that live in habitats where the bottom is too rugged to use nets. Today, nets of various types account for most of the commercial catch. Gill nets capture fish because of the fish's gills get entangled. Gill nets may be moored or drifting. Drift nets are efficient collection devices. Their use burgeoned up in the 1980s, when it was estimated that the amount of drift nets in use globally accounted for about 80% of the Earth's circumference. The use of drift nets became controversial because they were actually too efficient, and their use in the high seas was banned in 1992. Trawl nets are pulled along the bottom to capture fish. Trawl nets became popular after the proliferation of power to move vessels and to land the nets. Originally, trawl nets had a beam to keep the net mouth open, but the rigid beam created problems for landing the net and its contents, and this precipitated a change to a design called an otter trawl. Trawl nets have undergone a great deal of evolution, from beam to otter, to keep the net open, to locate the bottom, and to even tell how much fish has been caught and or exclude turtles. Trawl nets are used to capture shrimp, cod, haddock, whiting, and flounder. Over time, the use of bottom trawl nets has attracted increasing concern due to the destruction of benthic habitat in areas of frequent fishing efforts. The purse seine is by far the most important technique for catching fish that is in use today. Purse seines are so named because they're closed at the bottom like a woman's purse. Purse seines are used to catch fish that aggregate into large schools and live near the surface. Purse seines are used for fishing herring, capelin, mackerel, anchovy, and skipjack and yellowfin tuna. Purse seines may be very large and may be accompanied with numerous advances to better locate, encircle, and land large amounts of fish. Around the early 1890s, steam-powered ships came into common use and were used to haul the small open fishing vessels, such as dories, out to and from the fishing grounds, and this expanded their range. Then in the 1930s, gas-powered boats began to make their appearance, and this again increased the locomotion capability and therefore the range. This advance was followed closely by additional use of the power drum to draw in the nets, which increased the collection capability. And this was subsequently followed by the use of synthetic fibers, which were easier to handle, lasted longer, and were better at catching fish. Around 1930, Clarence Birdseye invented the deep freeze system, following his experiences in the Arctic. And over the coming decades, this had the effect of drastically increasing the demand for fish. No longer were fish available only to the coastal communities immediately adjacent to fishing ports, because now preserved, that is frozen fish, could be available to the entire inland regions of continents, and those mouths wanted fish. These pictures compare a typical trawl catch and a typical gill net catch associated with the pre-industrial fishing. Note that the cod end of the net on a factory trawler is bigger than the entire boat that was used in pre-industrial fishing. But the real sea state came in fishing after World War II. This is when all of the technological innovations that have been developed to find, stay, and shoot one another at sea were directed to finding and harvesting fish. The use of powered everything simply exploded on the fishing market. There were echo sounders to locate schools of midwater fish. This took away much of the guesswork and led to unproductive sets. Evolution of synthetic fibers made nets stronger, cheaper, more invisible, and more disposable. This meant that more time fishing with better collection devices and less time repairing the collection devices. Power allowed the use of bigger nets, which caused larger harvests, and the application of preservation technologies at sea, all of which resulted in the harvest of more fish. New technology allowed the fishermen of all countries to go farther, stay longer, better find fish, catch more fish, process them, and preserve those fish caught at sea. The last issue that's affected the seafood is something called tragedy of the commons.
The tragedy of the commons is the fate of any resource held in common ownership, when the collective ability of the stakeholders to consume the resource exceeds the capacity of the resource to renew itself.
That is, the consumers can take more out of the resource than the resource can replenish itself. In such cases, each stakeholder or owner then perceives that his own best interests are served by consuming as much of that resource as possible before it disappears. Under such conditions, the resource will surely vanish unless the stakeholders agree among themselves to constrain their use of that resource so that some greater, longer-lasting, sustainable good will occur and accrue to them. So let's review the 5 primary forces that have been at work to affect our supply of seafood and the sustainability of that seafood. The first is population. The second is improvements in technology. The third has to do with changing nutritional demands and desires by the population. The fourth has to do with cultural inertia. And the last has to do with something called tragedy of the commons. As we look at a number of the fisheries around the world, we saw that the combination of these forces were causing some problems in some areas. For example, the North Atlantic cod, for some of the whales, for the bluefin tuna, for the Chilean sea bass or the orange roughy. These were populations that were being harvested in excess of their capability to replenish themselves. And it is under those conditions that fishing has to be managed and constrained. Just as technology had a very big role in causing the excess fishing or in allowing us to have the capability for excess fishing, technology is also being brought to bear to improve our knowledge about the population so that they can be better managed. What's being done? Fisheries scientists and regulatory agencies and fishermen are working together to develop management plans, to develop quotas, and to collect the data that is going to enable the sustainable management of these fisheries. This is not an easy process. This is going on all around the world. And the technologies of aquaculture are also being brought to bear to supplement the population's demand for fisheries products and seafood.